For decades, psychiatry was kind of working in the dark. We had treatments that worked, but we often had no idea why. It was more about lucky accidents than smart design. Well, that is all starting to change. In this explainer, we're diving into a massive breakthrough that finally connects some of the most powerful and, honestly, the most bizarre rapid-acting antidepressants we have.
Okay, so what do a party drug, electric shocks, and a low-oxygen chamber all have in common? I know, it sounds like the setup for a really weird joke, right? But believe it or not, these are three of our most powerful, fastest-acting weapons against severe depression. And for years, nobody could figure out the link. Today, we're going to crack that case.
For the longest time, the field has been totally stumped by this. We had these incredibly effective therapies, but on the surface, they had absolutely nothing in common. There was just no unifying theory, no single story to explain why they all worked so well.
So let's meet the suspects in our mystery. First up, you've got ketamine. That's a drug, a pharmacological approach. Then there's electroconvulsive therapy, or ECT, which is all about electricity. And finally, acute intermittent hypoxia, which is basically a controlled physiological stressor using low oxygen. So you've got a drug, electricity, and low oxygen. I mean, you can't get much more different than that.
And that was the heart of the mystery. They were all so different, but they all gave people incredible, fast relief, sometimes within hours, when nothing else had worked. But if you don't know why something works, you can't make it better. You can't design safer alternatives. You're just stuck with the things you stumbled upon by chance.
But then, everything changed. Thanks to some amazing new tools in neuroscience, researchers finally found the clue they were looking for. They found the single, unifying thread that ties all three of these treatments together. And wow, is it a game changer?
The answer, it turns out, was shockingly simple. All three of these completely different therapies trigger the exact same event in the brain's mood circuits. They cause a huge, rapid surge of one single chemical.
And what is that chemical? It's called adenosine. Now, you might not have heard of it, but trust me, you deal with it every single day. Adenosine is a fundamental part of your brain's energy system. As you go through your day, it builds up and makes you feel sleepy. You can literally think of it as your brain's natural brake pedal, telling your cells, hey, slow down, time to conserve some energy.
And this is it. This is the big reveal. The drug, the electricity, the low oxygen, they're all just different roads leading to the exact same place, a massive, temporary flood of adenosine right where the brain needs it most. This is the common pathway that scientists have been searching for decades.
And look, this isn't just a small little update. This is a fundamental shift in how we think about depression. It suggests that maybe the fast-acting solution isn't about boosting serotonin like we've thought for so long, but about triggering this very specific metabolic event. It gives us a completely new target to aim for.
Okay, so we've got the what, this adenosine surge, but what about the how? How do these treatments actually cause it? Well, cracking that part of the case led to another huge surprise, especially when it came to ketamine. It turns out the story we've been telling ourselves just wasn't the whole truth.
For years, the leading theory, the one everyone believed, was that ketamine worked its magic by blocking a brain receptor called NMDA. But this new research shows that's probably not the main event. Instead, the real power comes from what ketamine does directly to the cell's tiny power plants, the mitochondria. It's a metabolic story, not a receptor story. And here's how that chain reaction works. First, ketamine basically slams the brakes on the mitochondria, telling them to chill out on energy production for a minute. That makes the cell's main energy molecule, ATP, take a nosedive. The cell immediately senses this energy crisis, and as a safety measure, it releases a flood of adenosine. And it's that adenosine surge that kicks off the whole cascade of antidepressant effects.
Okay. Now, this is where the story gets really wild, and where all this high-level brain science connects to something millions of us do every single morning. We have to talk about coffee.
So, why does coffee wake you up? Simple. Caffeine works by blocking your adenosine receptors. It literally gets in the way of that natural brake pedal, adenosine. So this creates a huge paradox, right? If these incredible treatments work by causing an adenosine surge, what does it mean that the most popular drug on the planet works by blocking it?
And here's the twist. Get this. Huge studies have shown that people who drink coffee regularly over the long term have about a 25% lower risk of developing depression. That is a massive protective effect. So caffeine, the adenosine blocker, seems to prevent depression. How on earth can both of these things be true?
Well, the secret is all about the difference between long-term chronic use and short-term acute use. Your daily coffee, over months and years, seems to have a really positive protective effect. But having a coffee right before you get a treatment like ketamine, that's a totally different story. That fresh, acute dose of caffeine could be sitting on those receptors, blocking the path for that all-important therapeutic adenosine surge.
So what does this all mean for the future of mental health care? It means we are finally moving out of the era of just getting lucky and into an age of designing treatments on purpose with a clear roadmap.
This is the crucial point. We are moving from serendipity to science. For the first time, we're not just hoping something works. We have a biological principle. We know the target we need to hit, that adenosine surge. And that means we can start building therapies with incredible precision.
And this just blows the doors wide open for what's possible. We can now design safer drugs that are laser-focused on boosting adenosine without all of ketamine's side effects. We can perfect non-invasive options like hypoxia. We can have much smarter conversations with patients about stuff as simple as their coffee habits. And we can use adenosine as a biomarker to find the next generation of antidepressants way faster than ever before.
And this isn't just a theory. It's already happening. Researchers have already created new molecules based on this idea. Just look at this. A new compound called DCK gets the same antidepressant effect at 1/5 the dose of ketamine, and it causes way fewer side effects. This is pretty much the holy grail in drug development. It's proof that we can surgically separate the good stuff, the therapeutic effect, from all the unwanted side effects. We can finally isolate the mechanism we want and get rid of the noise.
This quote just nails it perfectly. We've gone from just noticing that something works to understanding the deep biological rule that makes it work. We've turned a lucky guess into a guiding principle that can shape the future of medicine.
And that leaves us with one last, really big idea to chew on. This whole discovery, at its core, is about the brain's energy metabolism. So as we get better and better at decoding these basic metabolic secrets, is it possible that the next great leap in mental health care won't come from a new pill, but from optimizing the very habits that power our brains every single day?